For how many integers n between 1 and 100 does x square plus x minus n factor into the product of two linear factors with integer coefficients? Since x square plus x minus n is a quadratic expression, its most general linear factors can be written as ax plus p and bx plus q, so that x square plus x minus n is equal to ax plus p multiplied by bx plus q, where a, b, p and q are constants. Or if you multiply ax plus p with bx plus q, we get x square plus x minus n is equal to abx square plus aq plus bp whole multiplied by x plus pq. Now, there is an x square term here, x square term on the right hand side. There is a x term here, there is a x term in the right hand side. And this is a constant term, and there is a constant term here. So, by equating like terms on both sides of this equation, we get abx square is equal to x square, or ab is equal to 1. Let us call it equation 2. Then aq plus bp multiplied by x is equal to x. Therefore, aq plus bp is equal to 1. Let us call it equation 3. And the last is pq is equal to minus n. Let us call it equation 4. It is specified in the question that the two factors ax plus p and bx plus q have integer coefficients. That means a, b, p and q are all integers. Simultaneously, ab is equal to 1 from equation 2. This implies that a is equal to 1 and b is equal to 1. Otherwise, only one of them can be an integer, and that will make the other equal to the reciprocal of that integer. For example, if a is equal to 3, b has to become 1 by 3 to make ab is equal to 1. That is, then b is not an integer. But if a is equal to 1, then b is equal to 1 by 1, that is 1, which is also an integer. Therefore, we conclude that a is equal to 1 and b is also 1. It is given that n has to be a positive integer between 1 and 100. Hence, minus n is a negative integer between minus 1 and minus 100. From equation 3, that is aq plus bp is equal to 1, we conclude that p plus q is equal to 1 because we have already found out that a is equal to 1 and b is equal to 1. The implication of equation 4, that is pq is equal to minus n, is that p and q are of opposite signs, and their product can be any integer from minus 1 to minus 100, because n has to be between 1 and 100. Before going any further, please like, subscribe, share and hit the bell so you can be immediately notified for new uploads. It's completely free and only takes a few seconds, and you can always unsubscribe later if you want to. More importantly, for me, if you like, share, and subscribe, it would encourage me to make and post new videos for you to view. Also, if you know about any interesting problem that you would like me to solve, please upload it in your comments. Without further ado, let's proceed with the rest of the video. So, we have found out that P plus Q is equal to 1 and P multiplied by Q is minus 1 to minus 100. These two conditions give the following solutions for P and Q. This is given in this table. P could be 2, 3, 4, 5, 6, 7, 8, 9 or 10. Simultaneously, Q can be minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8 and minus 9. So that P plus Q in each case is 1, which is required. And P multiplied by Q in the first case is minus 2, in the second case it is minus 6, third case it is minus 12, fourth case it is minus 20, fifth case it is minus 30, sixth case it is minus 42, seventh case it is minus 86, eighth case it is minus 72, and ninth case is minus 90. Note that if P is less than 2, say 1, then Q has to be 0 and that would make PQ is equal to 0. Then minus n would be PQ and that would be 0 also, or n would become 0. This makes the value of n to go outside the range of 0 to 100, which is not acceptable. Similarly, if P is greater than 10, say 11, then Q becomes minus 10. That would make P multiplied by Q is equal to minus 110. Therefore, N would become minus PQ, that is 110. This value of N is outside the given range and therefore not acceptable. So, the only values of P and Q are those given in the table here and here. Therefore, only those 9 sets of values given in the above table are acceptable. For these 9 sets, the corresponding values of n are n is equal to minus pq is equal to 2, 6, 12, 20, 30, 42, 56, 72 and 90. Therefore, 9 integer values of n as given above are the only values that meet the criteria specified in the question. Thank you. This is the answer.